Hey everyone, welcome back. This is Ms. Martin. Today we're going to talk about valence electrons and the octet rule and why on earth those things actually matter. Because the real fact of the matter is, why is chemistry cool? Because you can make things go boom, right? That's the thing that we're looking for. Or making something change colors, or even the fact that we can go ahead and change foods so that they can last longer because of specific chemical reactions. And those are all because of valence electrons and an atom's desire to have a full outer shell, or what we call the octet rule. So I'm going to go ahead and get started, try to make this as quick as possible for you. First thing I want to show you here is just a really quick rundown, and you'll have to enjoy my ghetto version of this. Valence electrons are something that we've talked about. I like to call them boss electrons because, let's be real, they're the bosses and they make the decisions about what's going to happen chemically. So the first thing that we want to note, right, is that they're found in the outermost shell, okay? And that's really, really important for us because we don't want to get distracted by all those other electrons that could be in an element, like one that has 112 electrons, right? That's not how many are in the outermost shell. It's just the ones in that outermost shell based on the column that that specific element is in. And if you remember correctly, those elements are actually in those columns because of the number of valence electrons that they have. Another thing that we want to note here also is that they determine how, of course, the element is going to react, which is really important for us. And that number can be found based on the column that it's in, and we ignore the valley of transition metals. So we just look at columns 1, 2, and then you skip all the way to column 13, and you cover up that 1, and then 13 through 18 is going to let you know that you've got 3, 4, 5, 6, 7, and 8 valence electrons. The next piece that we're going to talk about here is the octet rule. Really straightforward. Octet is 8 in Latin, and so that is actually what I would like to say is why chemistry happens, right? So those valence electrons, all elements, they want to have a full outer shell, which means that they want 8 valence electrons. Now that could be 8 if it's any shell above the first one. If it's the first shell, you're only going to have 2 valence electrons there because that's all it can fit, right? So that's our exception, like hydrogen, helium, lithium, beryllium. Those are all some options or examples of elements that actually are going to try and have an outermost shell, which is the first one for them, with just 2 valence electrons. Otherwise, everybody else follows the octet rule of having 8. Another thing that we just want to note is those noble gases all the way at the end. Those are in column 18, which means they have 8 valence electrons or a full outer shell. So we call them inert because they don't react really with anybody else. All right, so our last piece here that we want to talk about is going boom, right? So we're looking here at why does this matter, right? And I've already kind of talked about that a couple of times here, but I want us to note all elements want to get a full shell the easiest way possible. So nature is just like us because we're a part of nature. We're going to do the easiest thing possible. Just think about water finding the easiest path. Electrons and elements are going to do the exact same thing. So when we look at the periodic table here, you'll want to note that those in columns 1, 2, and 13, or number 3, are going to try and get rid of those valence electrons that they have because they have very few of them in their outermost shell, and it would take more work to get 6 more or 7 more valence electrons. So instead, they just try to get rid of the couple that they have in their outermost shell so they can drop down to that next shell that is already full. And then if we're looking over here at our nonmetals, those are columns 15 through 18, they're going to try and gain electrons because it's easier for them to gain a couple of electrons, 1, 2, 3, versus trying to get rid of 5 or 6 or 7. And that's pretty much all there is to it. Our metals are wanting to lose electrons, and our nonmetals are trying to gain electrons. So good luck on your work, and I hope this helps.